Good evening, all of you. Audio, video clear. Good evening, all of you. Okay, so welcome all of you. Today's topic is surds and exponents. Please try to invite your friends also to be part of this free lecture series. This course is particularly useful for the upcoming UPSC exam and for other exams like GATE, CSIR NET and other aptitude tests. But the syllabus of UPSC CSAT will be fully covered in this course. So share it with all your UPSC CSAT preparing aspirants or those who want a guidance for UPSC CSAT or a final revision for UPSC CSAT. You can invite all those people and you can share it in Telegram or WhatsApp groups also. And CSIR NET and GATE aspirants, for you also this will be very useful. So in 30 minutes we are learning one topic. So today the topic that we are learning in 30 minutes is surds and exponents. Powers, how to deal with it. For the new people, my name is Christy Varghese. These are the books I have written and these are the courses I offer in my mobile application Christy's classes. If you want the flashcards as an ebook, that is also available in Christy's classes mobile application. 100 flashcards for UPSC CSAT, 100 flashcards for CSIR NET general aptitude. For CSIR NET exam and GATE exam, there are complete courses in the mobile application. GATE complete course will be announced very soon. That will be starting in 1 or 2 months. So that also CSIR NET GATE aspirants can follow that. UPSC aspirants, if you want, you can check out this flashcard series in the mobile application Christy's classes. In the description of the video you can find the link of all these courses and all these resources, and free resources are available in website christyvarghese.in, in Telegram channel Christy's classes, WhatsApp group and mobile application Christy's classes. Link of all these resources are there in the description of the video. So check the description of the video. That is one request to all of you if you want to get updates of all our free resources. And you can scan these QR code also, that way also you can be part of it. And check out this YouTube channel for more content. For different courses we are posting content. We are planning for a course on SSC exams also, that will be announced in some days. So subscribe the channel and hit the bell icon for more quality content in the future. You will get updates of it whenever I go live or whenever I post a community tab update. You will be getting updated if you are following the channel and hitting the like button. Okay, so this is the complete schedule of the course. So today's topic is surds and exponents. So surds and exponents, I have summarized the basic things you should know from surds and exponents in this flashcard. Basically we can divide it into how to multiply and divide when the bases are same, that is first category. How to multiply and divide when the powers are same, that is second type of rules or formula that you should know. Third category is when power of power comes, what to do. And fourth one is some basic assumptions or some basic notations we have. What is the meaning of fractional power? What is the meaning of negative power? What is the meaning of zeroth power? These things also you should know. We will discuss it one by one and then we will go to the trailing zero concept or number of powers of x in a factorial. These concepts also we will discuss. And last digit of a power, there is no time to discuss last digit of power today in this class. UPSC exam mein one time only directly last digit of power question was asked. One more time indirectly it was asked. I have already given a video on last digit of power in this channel. Those of you want to learn more about last digit of power, you can check out that video or check out this flashcard. This flashcard is a very comprehensive way I have explained how to find last digit of any power. So that part I will be skipping, but these two ideas we will be discussing in detail because these two ideas are very important. Okay, so let us start. First of all, what is exponent form? What is exponent form you should know. Exponent form, logarithm form, these are all of you. I am audible properly now. Audio video is clear now. Please respond. And link of this live lecture is tagged in the live chat. You can copy it and share it to your friends so that they can also attend this live session. Okay, so exponent form means, for example, 5 raised to 4 means what? 5 into 5 into 5 into 5. In previous chapters also, we have seen numbers written in exponent form. So it is 5 raised to 4 means 5 into 5. Repeated multiplication is exponents. Repeated multiplication is exponents. That is clear to all of you, I guess. Repeated multiplication is exponents. Just a minute. So where 5 is called the base of the number, 4 is called the power or exponent of the number. 5 is the base and 4 is the exponent or power. In logarithm also, that is base and exponent itself. And this exponents written in the like fractional power, that is called surds. The values of square root, cube root or higher roots which cannot be further simplified, that is called surds. For example, root 5, root 7, etc. More about surds, types of surds and all we can discuss, but that is not very important due to lack of time. Lesser important or less important topics or less importance area we will be skipping in this lecture. So basically what is surds you all know. Now exponents or surds, there are some common rules. As I told, when base is same, the numbers on the base is same, how to multiply or divide. For example, 2 raised to 4 into 2 raised to 3. Some people make mistake by saying 2 raised to 4 into 3 will be the answer, that is 2 raised to 12. No, it is 2 raised to 7. When bases are same, just add up the powers when you multiply. Just add up the powers. 4 and 3 should be added up. Why it is so? What is 2 raised to 4? 2 into 2 into 2 into 2, 16. What is 2 raised to 3? 2 into 2 into 2, 8. 16 into 8 is what? 128. 2 raised to 4 plus 3 is 2 raised to 7. That is also 128. 2 raised to 12 was much more than 128. It is 4096 actually. So that is not 2 raised to 4 into 2 raised to 3. So you can verify it by smaller number. That is what I am trying to say. Same way, when division also, you have to subtract the powers. 2 raised to 4 divided by 2 raised to 3 is 2 raised to 4 minus 3. So a raised to m divided by a raised to n is a raised to m minus n. Hope this is also clear to all. So this is when bases are same. Now what about powers being same? Exponents being same. A raised to m into b raised to m. A raised to m divided by b raised to m. How to multiply and divide? Just combine what is there in the base. A into b the whole raised to m. And here a by b the whole raised to m, because here it is division. For example, 2 cube into 3 cube is 2 into 3 the whole cube. This can be easily understood by understanding what is 2 cube. 2, 2, 2, 3 times. Now, what is 3 cube? 3, 3, 3, 3 times. Now, this 2 and 3 multiplied you will get a 6. This 2 and 3 multiplied you will get a 6. This 2 and 3 multiplied you will get a 6. That means 6 raised to 3 it is. Now, it is 6 into 6 into 6. That is what is written in a mathematical form as a raised to m into b raised to m as a into b the whole raised to m. The bases can be multiplied. And if it is division, the bases can be divided. 8 cube by 4 cube is 8 by 4 the whole cube. 8 by 4 the whole cube. That also 8 cube is what? 60. 8 square 64 into 6 324 divided by 4 cube 64. When you divide it, you will get it as 88 itself. Or the shortcut is you don't have to expand it. You just have to say 8 by 4 2 the whole cube. It is 8. Simple now. So when the powers are same, how to multiply it and divide we discuss. Now what about power of power? Power of power, how to simplify it? 2 raised to 3 raised to 4, 2 raised to 3 the whole raised to 4. Both are different. Please understand. When bracket is there, that means that step should be done first. That step should be, Bodmas rule says bracket should be done first now. The 2 raised to 3 the whole raised to 4 means 2 raised to 3 is 8, 8 raised to 4. 8 raised to 4 is 4096 when you calculate it. But there is a shortcut for that. That is what this rule says. A raised to m the whole raised to n is a raised to m into n. When there is a bracket, you can multiply the powers. You can multiply the powers. M and n can be multiplied. 2 raised to 3 the whole raised to 4 is 2 raised to 3 into 4. 2 raised to 12. 2 raised to 12 is also 4096. So you can do it in two ways. Either you simplify 2 raised to 3 and then raised to 4. Or you multiply 3 into 4 and then 2 raised to that, because that is easier to calculate. All of you are following, please respond. But when there is no bracket, that means it is called tower rule of exponent. Tower rule of exponent means powers should be done first. It should be, top to bottom is the natural order. Top to bottom. No bracket means top to bottom is the natural order. M raised to n should be done first. That is 2 raised to 3 raised to 4 without any bracket means That means this 3 raised to 4 should be prioritized and that should be done first. 3 into 3 into 3 into 3 is 81 now. So 2 raised to 81. If you do the other way around, you will get a wrong answer. That is what I am trying to say. 2 raised to 3 first you will get 4096. 2 raised to 81 is much more than 4086. Powers are different means. Powers are different means you cannot use any of those shortcuts, Shanti. There I will tell you how to do it with questions. When there is a need arise, I will discuss about that. So this much is clear. Please respond. So what we discussed till now was these first 6 rules. 6 rules in this flashcard. 1, 2, 3, 4, 5, 6. Now what about fractional power? Reciprocal power. 1 by m. A raised to 1 by m. 125 raised to 1 by 3 means what? 125 raised to 1 by 3 means 125's third root it is. Third root of 125. Third root of 125. So if it was 25 raised to 1 by 2, that is second root of 25. 5 it is. That does not mean always you can simplify it that easily. I am showing you examples that simplifies faster because I am showing you the concept. So if it is 64 raised to 1 by 3, tell me the answer. And 64 raised to 1 by 2, tell me the answer. All of you. What is 64 raised to 1 by 3? What is 64 raised to 1 by 2? All of you answer. What's the answer? Very good. What 64 raised to 1 by 3 means third root of 64. Third root of 64 is what? 4 into 4 into 4 is 64. What is the meaning of third root? What number multiplied with itself 3 times will give you 64? 4 into 4 into 4 is 64. Now 4 into 4 into 4 is 64. So 4 is the answer. 64 raised to 1 by 2 means what? Second root of 64, square root of 64. That means which number multiplied by itself 2 times, you will get 64. 8 into 8 is 64, so 8 is the answer. Is it clear, all of you? So reciprocal of positive power is negative, fractional power means 1 by m means mth root of a. Mth root of a. Mth root of a. Hope that is also clear. So that is clear. Now what about negative power? Negative power means reciprocal of positive power. Reciprocal of positive power. For example, 4 raised to minus 2 क्या होगा? 1 by 4 raised to 2 होगा. 1 by 4 raised to 2 होगा. 4 raised to minus 3 means 1 by 4 raised to positive 3. That is 1 by 64 होगा. Reciprocal of negative positive power. And this was directly asked in a CSAT question in 2020. Whether you know negative power or not. If you don't know that single concept, you cannot do this question because it is totally based on that concept. And if you know that concept, this question is super easy. So please try this super fast, all of you. Very good. Some of you got an answer. And those of you watching this session live, do hit the like button because that will help this video to reach to more and more people. Only if you felt this feeling that the session is useful, do hit the like button because that will mean a lot. That this I will be so happy if more people get to know about this course and more people join this initiative. That is why let YouTube suggest this video to more and more people. If you like, if more of you like this video, YouTube itself will recommend it to more people, and definitely you can personally recommend it to your friends if you feel that this series is useful for them, especially for UPSC and other general aptitude related exam preparing aspirants. This will be very useful. Okay, so many of you got the answer. Let's see whether it is correct. What is the largest number among the following? 1 by 2 raised to minus 6 what? Minus 6 means what? 1 by 2 raised to 1 by 1 by 1 by 2 raised to 6. 1 by 1 by 2 raised to 6. 1 by 1 by 2 raised to 6 means 2 raised to 6 na? So this is nothing but 2 raised to 6. If that is 2 raised to 6, this is 4 raised to 3. This is 3 raised to 4. And this is 6 raised to 2. All of you are getting this. Now you simplify this. Now you know how to simplify it. 2 raised to 6 means 2 into 2 into 2 into 2 into 2, 6 times. That is 64. 4 cube is 64. 3 raised to 4 is 81. And 6 raised to 2 is 36. Which is the largest number? 81. Option C. Super easy, na? Otherwise, more steps I have written here. Yeah, if you write 1 by 1 by 2 the whole raised to 6 or 1 by 1 by 2 raised to 6, both means the same itself. All clear? So that was purely based on this idea, whether you know negative power is 1 by positive power. So it is not so much tougher math that is asked. Most of the question it is elementary math that is being asked. Some questions only like little more higher math, like 11th class math. UPSC syllabus it is mentioned that 10th class up to 10th class math only should be asked. But permutation combination chapter and all, they ask even 11th class, 12th class math also. When we discuss that chapter, we will discuss more about it. So what is negative power? We understood it. Fractional power, this part you can skip it. Question we are not asked yet. Zeroth power is 1. Any number raised to 0 is always 1. Any number raised to 0 is always 1. Hope that is also clear. So, and this was a 2022 PYQ based on Surds and Exponents. So, can you try this super fast, all of you? After this, we need to discuss about trailing zero concept, number of digits in a power concept, etc. Very important concept. So, please try this super fast. We'll get some water and come. All of you try this question. Okay, some of you got an answer. Let's see. This question actually, if you use the right method, you can do it super fast. This options itself is the key. I have told many times you can do questions in different ways. In previous videos also we discussed about 15 shortcut methods to do general aptitude. So if you people are interested, we will plan for another series like this before the upcoming exams. So discussing about this shortcut methods in detail. Already a playlist on that is given already. You can check out the playlist where I have explained about the shortcut approaches. So here elimination with related option is the best method to do this question. Elimination with related option. Elimination itself can be done in 5 ways, minimum 5 ways. So here elimination with related option, how to do it I will show you super fast. So first of all, 2 raised to 40, 3 raised to 21, 4 raised to 18, 8 raised to 12. ऐसा questions में the questions like this, what you should do is try to make the base same or power same. This is 2, this is 4, this is 8. 8 is 2 cube, na? 4 is 2 square. So they are powers of 2. So you can write 2 raised to 40, 2 raised to 2 the whole raised to 18 you can write. Now instead of 4, if I write 2 raised to 2. That will make everything in base of 2. We are trying to make the base same or power same now. And here it is 2 cubed the whole raised to 12. And now you can apply the rule we just discussed. A raised to m the whole raised to a raised to m the whole raised to n is a raised to m into n. Or the reverse, a raised to m into n is a raised to m the whole raised to n. Because in this case, we are seeing it in 2 raised to 2 raised to 18. I told you you can do this as the base can be done first. That is the normal way. Shortcut method is multiplying the powers. So 2 raised to 2 is what? 4. So it is 4 raised to 18. And 2 cube is what? Sorry, one second. You have to use a raised to m the whole, a raised to m into n itself, because taking the base you will end up with the same initial value itself. Now, so 2 into 18 if you do, then you will get it in base of 2 itself. A raised to m the whole raised to n is a raised to m into n. So 2 raised to 2 into 18 is 2 raised to 36. And this is 2 raised to 40. And this is 2 raised to 3 into 12, that is 2 raised to 36. And here there is a 3 raised to 21, let it be there. Now look at this, this is 2 raised to 36, this is 2 raised to 36, and this is 2 raised to 40. We need the smallest value. When we are searching for smallest value, we are not worried about larger value at all. 2 raised to 40 is clearly larger than 2 raised to 36. The larger values we don't want now. So definitely 2 raised to 40 can be eliminated. Now 2 raised to 36, 2 raised to 36. Look at this. Here you can do identifying related option or elimination with related options. Option C and option D are related because both gives you the same value 2 raised to 36. That means if this is the smallest, this is also the smallest. 2 option being smallest is not allowed in UPSC exam, or 2 options being correct is not possible. It's single answer type questions in UPSC. Not only UPSC, most of the exams, multiple answer type exams are very less in India. The most Indian competitive exams, aptitude section part, subject part in some exams, many exams multiple choice or multiple answers are there. But aptitude section in most of the case it is single answer type. Single answer type means in this question clearly, if this is the answer, this is also the answer. 2 answers are impossible. That eliminates these 2 options. This was already eliminated because 2 raised to 40 is bigger than 2 raised to 36. And 3 option elimination gave you the remaining option as the answer. Did you all understood this? So that was the easier way of doing this question. So we didn't prove that 3 raised to 21 is the smallest, but we disproved that other options are not the smallest. That is one thing you should understand. The invalidity of 3 options confirms the validity of remaining option. Some people have trust issues so much that even if they understood that these 3 are not the smallest, they are still not happy with concluding the remaining is the answer. They want a proof for 3 raised to 21 is the smallest. Then they will waste time on expanding 3 raised to 21 and all. No, you should not do that. In competitive exams, descriptive exam approaching and objective exam approach are totally different. It's an objective paper. So objective paper should be done that way itself. But if the option 3 raised to, then you have to do other approaches, Sabin. 3 raised to something means it is very simple now. We already have a 3 raised to 21. We have a 3 raised to something means that if it is more than 3 raised to 21, that will be not the smallest. If it is less than, that will be the smallest. Yeah, let me tell you frankly, the objective of UPSC when they ask this question is to check whether you are doing this elimination techniques and all. That is what I believe. I am not thinking that this is one method I just discovered. No, UPSC when setting this question itself may have thought that, okay, let us put a small thing like this in this question, so that students, if they are smart enough to identify that, they will get the answer faster and get 2.5 mark easily. Logarithm, again, logarithm you can do if you know logarithm values, at least few of them, Sabin. Otherwise that is also difficult, na? Yeah, log 2, log 3, log 4, etc. If you by heart it, then you can apply logarithm. But by hearting, we are trying to keep it as minimum as possible. If you already know it, definitely you can use it. Nothing wrong with it. But I am not depending on that idea, because in the last minute making you telling you that you should buy hard this many things more. That will be counterproductive in my opinion. That is why we will go to the next concept, trailing zero concept. That this was also asked multiple times in UPSC, also in the other exams also. CSIR exam also the same concept was repeated 2-3 times. Okay, listen carefully. So for learning the trailing zero concept, first you should know how to identify the number of powers of x in a factorial. I hope all of you know what is a factorial, because that is something that is needed in permutation combination chapter also. 3 factorial is 3 into 2 into 1. 4 factorial is 4 into 2 into 3 into 2 into 1. N factorial is n into n minus 1 into up to 1. The factorial is clear. So if the question is written in a factorial, what to do, we will discuss about that. If question is not written in a factorial, what to do, that also we will discuss. We will start with a simple question. This is a common structure of a question of this topic. If 12 into 20, 16 into 20 into 27 is 3 raised to m into n, we discussed about prime factorization in the previous 2-3 chapters. So when you are writing it in prime factorization, 3's power is m. That is what 3 raised to m means. So what is the value of that m? So how many 3's are there in this expression? That is a simple way to understand this question. So one way of doing it is you can prime factorize each of the numbers. This is 3 into 2 square. This is 2 raised to 4. This is 2 square into 5. This is 3 cube. So this 3 and this 3 cube will make a 3 raised to 4. We don't want what is n. We want only the value of m. So that is 4 na. All of you understood? So the meaning of the question all of you understood na. In this case 2 raised to m. So m value means here there is a 2 square, here there is a 2 raised to 4, here there is a 2 square. So 2 square. Now loss of exponents, you are adding up the powers. 2 raised to 2 plus 4 plus 2. That is 2 raised to 8. So 8 will be the value of m. All of you are getting the point. Similarly, if it is 5, here there is a 5, no other 5 in any other number. So m value is 1. Due to lack of time, we will go to the next idea extended of this. Here there is no factorial. What about factorial? There also you can use the same idea. What is factorial means? 5 factorial means 5 into 4 into 3 into 2 into 1 na? And then you can say that this have a 3 in it, no other number have a 3 in it. So value of m is 1, because 3 raised to 1 only will be there. But for 5 factorial it is okay. What about 50 factorial? Writing all 50 numbers and identifying how many powers of 3 will be very time consuming now. That is where this rule will help you. For example, if this is the question, 50 factorial equal to 3 raised to m into n, if you want to find the value of m. 50 factorial is 50 into 49 into up to 1 now. So to find the number of 3's, what you should do is take 50, divide it by 3. Take the natural number or integer value of that. 50 by 3 integer value is what? 16. 48 by 3 is 16. Nah? So 50 by 3 is also 16. Reminder, forget about it. What is the quotient? That is what I am asking. This is not the answer. You have to then do 50 by 3 square. 3 square. 50 factorial means 50 by 3, 50 by 3 square. 50 by 3 square means 50 by 9. 50 by 9 is what? 9 into 5 is 45. So that is 5 is the quotient. Now you have to do 50 by 3 cube. 50 by 27, that is 1 now. Now you have to do 50 by 3 raised to 4. 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, etc. That is 50 by 81, that is 0. That means now if you take any number of any power, 3 raised to 5, that will all be 0 now. That means you can stop it here. When you get a 0, you can stop there. And add this, that is the answer. 16 plus 5 plus 1. 16 plus 6, 22. So 22 is the answer. The reason behind is very simple. If you write this numbers few, you will get an idea. Because 3 have 1 3 in it. 6 have 1 3 in it. 9 have 1 plus 1 3 in it. To find the extra 1, that is why you are dividing by 3 square. Again, new students, I think that will be confusing. Those of you already attended my classroom coaching program, I think you already remember we discussed this concept in detail. Now for the time's sake, we will just keep it as a formula or keep it as a generalized version. The number of powers of x in p factorial is integer value of p by x. Connect it with the previous question. Yeah, that is what is written here also. Powers of 3 in 50 factorial means 50 by 3, 50 by 3 square, 50 by 3 cube. Up to getting 0, you have to continue this. 50 by 3 raised to 4 onwards, you are getting 0. That is why you are writing only this. Because 0 added any times, you will get the same value. Na? All of you understood this? And this idea will help you to find the trailing zeros also. Trailing zeros. Before that, I will show you a PYQ where the same concept was asked. CSIR NET aspirants, this was a previous CSIR NET question of the same type. Due to lack of time, I will just go to the... Yes, this question. This question is literally the same concept itself. Na? 15 into 14 into up to 1 is what it is. 15 factorial. Yeah, tell me the answer, all of you. Please try it super fast and answer me. Okay, due to lack of time, I will start explaining. As it is 15 factorial, if it is p factorial, you have to do p by 3 square, p by 3 cube, etc. As it is 3. So 15 factorial, 15 by 3 plus 15 by 3 square plus 15 by 3 cube, etc. 15 by 3 is what? 5. 15 by 9 is what? 1. 15 by 3 cube is 27. That is 0. So you can stop it right away. 5 plus 1, 6. Here I am not saying that you cannot do with any other way. You can do with other ways also. 3, 6, 15 numbers, you have to take all multiples of 3. But some multiples of 3 have 2 times or 3 times 3 in it. That you have to be careful. That is why, to avoid mistakes, it is better to know this theory. Are you all understanding? And in CSAT, this is asked one more time. Here actually you can... Yeah, you can do this idea, but after using one more technique. Try it as a homework question. You can pause the video. I have given the explanation of this question in this slide. Or to those people who are not aware, we have started giving study material or practice questions for each of the chapter after every class. Next day you will get the practice question. 10 questions each you will be getting for each topic. So today's 10 questions you will be getting in tomorrow in our Telegram channel. So check the description of the video to be part of our Telegram channel so that you will get the study materials. Okay, so this idea is clear, I guess. Number of powers of x in p factorial. Now number of trailing zeros. What is the meaning of trailing zeros? Trailing zeros means how many zeros are in the end. How many zeros are in the end? That is called trailing zeros. For example, this question. Okay, 1 second. Yeah, this question. How many trailing zeros are there in this expression? This expression, to find the trailing zeros, what you can do is, trailing zeros or zeros in the end, for example, 30,000. What is this 4 zeros? So trailing zero here is 4. Because it is 3 into 10,000. So powers of 10 make 0 na? In the end. Zeros in the end are created by powers of 10. This is 3 raised to 10 raised to 3 into 10 raised to 4. And powers of 10 are created by 2s and 5s. 2 into 5 is 10. So how many 2s and 5s are there? Pairs of 2s and 5s will give you trailing zeros. Here 5s are 14 in numbers, 2s are 17 in number. But you can combine only 14 2s and 14 5s na? Remaining 2s you cannot take up. Pairs of 2s and 5s only you can combine. So pairs and 2s and 5s is 14 in number. So 10 raised to 14, so 14 zeros. You don't have to write these steps. This I am just elaborating. CSIR NET aspirant, this was aspirants. This is a previous CSIR NET question that I have just explained. So very connected concept itself. Number of, and what about trailing zeros in the case of a factorial? Yeah, due to lack of time, I will use this flashcard to explain this concept. trailing zeros, if it is an expression, find the number of pairs of 2 and 5 in the prime factorization. For example, 2 raised to 12 into 3 raised to 25 into 5 raised to 17. 2's are 12 in number, 5's are 17 in number, but pairs of 2's and 5's are only 12 in number. Na? Because even if 5's are 17 in number, you can only take 12 2's and 12 5's to make 12 10's. So that is why 12 is the number of zeros in the end. But what about if it is a factorial? If it is a factorial, powers of x I told you already. Yeah, simple thing is, if it is a factorial, say 50 factorial, you are finding pairs of 2 and 5 itself there. But number of 2's will be much more than number of 5's in a factorial. That you should keep in mind, or if you write few numbers, you will understand that. That is why it is enough to find the number of 5's in the p factorial to find the trailing zeros in a factorial. If it is factorial, please keep this in mind. So in 50 factorial trailing zeros, this first concept I taught you, that you apply for x equal to 5. If x equal to 5, 50 by 5, 50 by 5 square. 50 by 5 means 10. 50 by 25. 50 by 5 cube is 50 by 125, that is 0. So you can stop it right away. So 12 is the answer. Are you all getting? Because this is the number of 5's in it. Number of 5's in it will be the number of pairs of 2's and 5's in it. Because 2's will be more than the 5's. Because 2's are there in every even number. Even numbers occur in every 2 numbers. But 5's are only there in multiples of 5's. That is every 5 numbers only. Again, that is too many things to be explained. In brief, I just explained it. Now, if there is a power in this factorial to find the trailing zero, you just multiply by that power. That part, you can try it yourself. Till now, question was not asked based on this. But this and this questions were asked. And this also. And same thing. To find the number of digits also, you can use this concept. Try it yourself, the example given in this flashcard. So this is the basic ideas you should learn from this chapter. Hope all of you are clear about this. I tried to cover as much ideas in this limited 30 minutes. Once again, I am telling you, I am keeping the series as 30 minutes because that is a speciality. I want to keep it for the series. That is why I am not trying to extend it for 1 hour, 1.5 hours. Many of you requested me to keep it 1 hour, 1.5 hours. I respect your wish to make it 1 hour, but this series we will keep it 30 minutes itself. But so happy to see more and more people are being part of this initiative regularly. That is why we will plan for some other series in the near future. That we will keep it for longer time interval. This series, another reason why I am keeping it 30 minutes is, this is a series. I have told this in the first or second class also. Every day I have about 3 to 4 lectures or some other commitments that I have to complete. So after that, the end of the day, I take this 8:30 p.m. So my energy is also very less after all the other sessions. That is why taking for more than 30 minutes is difficult. But one way it is actually counterproductive, because when I'm trying to complete it in 30 minutes, I'm trying to speak faster and take more energy. So that way it is taking, it is more straining, but that is okay. I will manage somehow. Explain the factorial one. Factorial one for trailing zeros, or which one you are asking, Sriju? Factorial ones, as I have told, if it is 50 factorial, to find trailing zeros, find the number of 5's in 50 factorial. Number of 5's in 50 factorial means number of 3's in 50 factorial we discussed now. Same way number of 5's in 50 factorial. 50 by 5 plus 50 by 5 square plus 50 by 5 cube, etc. That is the idea. So trailing zero, let me see one more example I have. Yeah, if it is 15 factorial, trailing zeros, what you should do is 15 by 5 plus 15 by 5 square, 15 by 5 cube, etc. 15 by 5 is 3, 15 by 5 square is 0. So you don't have to write any further. So 3 will be the answer. Trailing zeros will be 3. Or if you write it down, you will understand why it is working. because 15 into 14 into etc. up to 1. Multiples of 5 are 5, 10, 15. Na? Each of them have 1 5 in it. 1 5 only. So 5 cube into 2 raised to something. That something is whatever it is. 5 are only 3 in number. 5 are only 3 in number. That is why 10s are also 3 in number. That is why zeros in the end are also 3 in number. Is it clear now, Sriju? So that is the idea. Hope all of you understood the concepts. So summarizing what we discussed today. First we discussed about laws of exponent. That is a basic logic or basic theory you should know for other concepts also. We discussed about base same, power same, and power of power also, and about negative power, fractional power, zeroth power, etc. Then we discussed about number of powers of x in a p factorial and number of trailing zeros, number of digits, etc. Go through this flashcard. I have tried to explain with this example itself. By that I hope you will understand it. And this concept I am trying to give it as homework. I have given a video on this. I will try to share this video link in our Telegram channel. Those of you who want to get updates from me, try to be part of our Telegram channel. You will get all updates. UPSC aspirant, there is a separate group. CSIR NET and GATE aspirant, there is a separate, not group, channel, sorry. We will plan for a group also, but currently it is channel. Check the description of the video to find the link of the Telegram channels. So that's it. Any other questions or any other feedback? And those of you attended the session, if you felt this session is useful, do hit the like button and do comment on this video and do share this video to maximum people, and make sure that you have subscribed the channel and hit the bell icon. Your feedbacks, your suggestions are all welcome, and some of you asked me about, even now some of you texted in WhatsApp regarding the full-length courses for CSAT. Currently there is no full-length course in this channel. I am associating with other institutes. As part of other institute it is there. In Kerala, in Trivandrum, Lead IAS, I am offering classroom coaching program. That also is mainly online now. And in Bangalore, I am part of one institute called Legacy IAS. And in New Delhi also, as online initiative, there is an online initiative. Classroom program, currently it is only in Bangalore and Trivandrum. You can inquire in that institute regarding that program. But current batch, I think it is concluding in one or 2 weeks. So upcoming batches we haven't announced yet. When we announce, you will get notified. So regarding my future courses and future endeavors, you will get updated in our Telegram channel and in our social media handles. So through that you can understand. I am telling this to those people who inquired about the full courses. So happy to hear that you are interested for the full length program for UPSC CSAT also. And CSIR NET aspirants and GATE aspirants, already programs are launched in my mobile application. UPSC, in the future definitely there will be programs, but currently it is as part of institutes only. Classroom coaching programs are there. When we divide by 5, how does it lead to 0? Divide by power of 5, Sriju. For example, 15 by 5 square is what? 15 by 5 square means 15 by 25. 15 by 25 quotient is 0. Na? 15 mango trying to divide among 25 people. You cannot divide, you cannot give even one mango to anyone, because you cannot equally divide. Na? Division means exactly divisible. In this context, that is division. राखी is asking HCF LCM class में एक question players meeting वाला उसको एक बात समझ दे दिए. One division वाला topic वाला से था 999 ABCD. वो 999 ABCD वाला question में option elimination से इसलिए कर सकता है राखी. Option elimination से मतलब ये example I am not remembering the question exactly. I think the question was ABCD should be prime numbers. Yeah, that was the question. So take this example and try Rakhi, you will understand it. ABCD को 2357 consider करना है क्योंकि 2357 है prime number. E को 000 consider करना है. E के जगह 000 consider करिए और वो question read करिए, आपको आंसर मिलेगा. अब तीन ऑप्शन एलिमिनेट कर सकता है if you are assuming E equal to 0 and ABCD as 2357. कौन सा ऑप्शन 4 वाला ऑप्शन, 5 वाला ऑप्शन और 8 वाला ऑप्शन एलिमिनेट हो जाएगा. उसके बाद बचा हुआ ऑप्शन सिर्फ 3 है. तो 3 होगा आंसर राखी. So that is how to solve that question. HCF LCM वाला कौन सा क्वेश्चन था, क्योंकि multiple questions were there on HCF LCM. So specify करिए, we will discuss that maybe on another class. So I think we will conclude here. Thank you all of you. Take care all of you. Have a good night, and share this video to more people if you feel that the session is useful. So thank you all of you. Tomorrow we will discuss the next topic. Next topic is miscellaneous number system concepts. Concepts like arithmetic progression, geometric progression, and other number system ideas we haven't discussed in the previous session. All of them together will be discussed in the next lecture. Miscellaneous number system questions or miscellaneous number system concepts. So that's it. Thank you all of you. Take care all of you. Have a good night. Bye bye.